All right, you people, we are finishing the notes 3.3. You guys got to add some things to your notes here in a minute. And because for some reason, when I saved the notes, they did not have these next identities, which are really, really important. So now, we're going to chain rule this. So chain rule here, to find the derivative, I'm going to start with, what is the derivative of the inside? The inside here is what? Yeah, right here. So 4x squared, right? That's the inside, right? So what's the derivative of the inside?
8x.
So I have 8x, right? So that's the derivative of the inside. So now the outside would be all of this out here. Now from the previous slide, the derivative of arc sine, is 1 over square root of 1 minus x squared. But in this case, what is my x? It's not just x, so it's 4x squared, right? So it's actually all of this. I'm not changing this. So this is going to be times the derivative of the outside, 1 over the square root of 1 minus,
16x.
nope,
To the
4x squared.
To the square.
Squared.
So it's like
I'm writing it all out. Okay, so I won't skip steps on this. Okay, so it's the x squared, but in this case, my x is all that, right? Okay, so now I could go ahead and put this together. So this is my y prime. Put it all together. So on top, I'm left with 8x. On the bottom, I'm left with square root of 1 minus 16x to the 4th. Not too bad, right? Okay. So does that help with the arc sine right there? You're just replacing it. It's not really much for the derivative. You just have to have these certain things memorized later on. Okay? So these, all the arcs were actually on your flashcards that I gave you. Remember those flashcards? Yeah. Okay, those flashcards, you need to make sure you find those. And when we take the test, which should be later on this week, okay, the test, you will have to know those ones by heart. Okay, you will have to know those arcs by heart. Okay, so there's your first one. So it's the arc sine. The next one is going to be arc tangent, and this thing, like I said, did not want to copy. I don't know why. Okay, so now, bam. Ooh. Let's see. There we go. There we go. There we go. Okay. All right. So for this one right here, the derivative of arctangent is 1 over 1 plus x squared. Okay, and now on this one, I have typo that I cannot stand. All right, so this is there we go. All right, makes that look better. Anyway, all right, so now let's go ahead and do this one. So given this much information, I could go through and say, hey, what's the derivative of the inside?
4.
Just 4. So it's 4 times the derivative of the outside.
1 over 1 plus.
So it's 1 over 1 plus,
16.
what's my x? 4x. And that's going to be squared, right? Okay, so now right here together, I get y prime is going to be 4 over 1 plus 16x squared. All right, so let's take a look at the next one. Too small. There we go. We have arc secant here.
How you will say this brackets in English?
This straight one?
Yeah. How you
Absolute value.
absolute value.
Absolute value.
But why it's not why x is not in absolute value when the bottom like 1 over absolute value x.
Okay, so now think of it like this. Like this right here. This is the domain. These are the restrictions that we're talking about here. This is the restriction. So the absolute value of x has to be greater than 1. There's a reason for that. What's inside, since I have a radical there, right?
But they're square. We don't care.
Oh,
Because
okay. Now, absolute value, because right here, inside that, if it is less than 1, what would happen inside there?
0 and 0.
I would get negatives, right? Because I'm subtracting 1, right? I'm subtracting 1. So, if I'm subtracting 1 from that, what would happen if I put something in there that is less than 1? That gives me less than 1. Negative. Am I allowed negatives inside a radical? Say no. No. The square root of negative, imaginary. Okay, where that would be an imaginary number. So that would be imaginary. So I'm not allowed to have that, right? And because it has to be right here, it has to be more than this. This thing right here, is it possible for it to be 0? Say no.
Like I mean,
It's not possible for it to be 0. Why?
because it can be.
That'll give you 0 in the denominator, which would be undefined, right? Does that make sense or no?
Yeah.
Hopefully. So, now, let's go through and that just give me my restrictions on that. And the problem I had for this one... Did I have a problem on this one? Nope, I did not have a problem on this one.
Just make it.
Yeah, so this right here didn't have a problem. It was just... There we go. All right, and so you guys have this copy down, right?
We have it on the flashcards.
Yes, you do, but it's also good to have on your notes. Man, I guess just some people from Russia are just lazy.
I'm not from Russia.
Yeah, this gradients are
That's
so.
very weird.
I know, he doesn't want to write it down for some reason.
Hey, I do.
That's not
That's wrong. Why did it put it in the notes when you printed?
I told you, I don't know why it did not save.
He's also lazy.
Yeah.
I already did these notes already with my Calculus 2 class. We already went through all this. All this, you know, it was all there, but then when I transferred it and saved it, those other slides did not make it to there. Okay, so I have to go back and add it again later. All right, these ones right here. So you actually have all of these now. So for this, inverse cosine, inverse cotangent, inverse cosecant. So you're going to have different values for each one.
Just changes the sign.
Maybe.
I mean, derivative is just changing. It's just putting negative before. That's it.
Are you sure? Is that what it is?
Yeah.
Are you sure?
Yes.
Positive?
Okay. Anyway, don't try and oversimplify it. Yes, it is on the notes. All right, you guys. So that's basically where I'm leaving you off for this. So you guys have all the identities now. You can finish up the practice. Don't forget, like and subscribe.
Nothing.
Wait.